And I'm live. That is cool. And today is 20th of July 2025, Sunday. And today was UFC 318. And Max Holloway defeated Dustin Poirier. And there were some nice knockdowns and some takedowns. Yeah, the fight was fine. It was not as great as was the earlier BMF fight, UFC 300. That fight was amazing. UFC 300 was fucking amazing. And yesterday was a Code Forces contest number 1038, and I participated in that. I was able to do two questions, and I got stuck on the third one. And let's review them and read the article, read the editorial, and begin this stream. Health, yep, stop myself. Code Forces. And there are always some updates in Vim plugins, Lua snippet and something. And this is the first one, pretty simple, very easy. Second one is this, and then the third one, which I was unable to do. I did a lot of things, but I was still in the end unable to do this. And Code Forces seems to be fucking down. That is very sad. Maybe another link. Why is it down from time? Let me hide my screen for a bit so that you guys cannot steal something. Enter login. Cool. Still, I'm not at the official Code Forces website. I can only see a competition. Fuck. And let me just log in. Simply log in. Simply log in. Okay. It seems that I cannot do that. I can log in, but Code Forces is down. So I can go here. See the questions. Can I read the editorial? I cannot read the editorial for these. Well, let's just explain. Let me just explain these questions and my solution for these, and hope that while I do that, Code Forces comes online. So in this question, a path is a path in a grid is called greedy if it starts at the top left cell and moves only to the right or downward, always moving to its neighbor with the greater value, or either if the values are equal. So this is one way that you can traverse a path, and a traversal algorithm is called greedy if it follows this particular algorithm, which moves right or down, mm, right or down towards the cell which has the greatest value immediately. If this is how a path is being traversed, then it is called greedy. And the value of a path is the sum of all the values in the cells that it visits from start to the end, including both start and the end. Then given a size, a grid of n by m, can I create a matrix, a grid, in which if I traverse by a greedy algorithm, then the value of that greedy path will not be the maximum possible value. So this was pretty straightforward, and now this is live. That is cool. Code Forces is live. Right here. Yes, I got a few points in yesterday's contest. Yes, and greedy path. So I am given n and m, and I have to figure out, is there, given this dimension of a grid, can I create a path in which the maximum possible value of a path is cannot be reached by a greedy path, by a greedy traversal. And yeah, this was that same question. And let's say if I have a matrix of A, of 2 by 2 matrix A, B, C, D. So if I start from A, which I will, so A is on my path, and then I will go either to B or to C, depending on whichever is greater. If B is greater, I will go to B, and if C is greater, I will go to C. But no matter which number I go to, I will next go to D. So I can add D for sure, and plus maximum A. Shit, my writing is amazing there. Maximum of B plus C. That would be the value of the path if I go using a greedy algorithm, either this path or this path. And this value would also be the greatest possible value if I were to travel using a path that is not greedy. So a 2 by 2 matrix cannot be formed in a way that I can achieve a path that it has the highest value, but that path cannot be achieved by a greedy traversal. But if my matrix or something like this, a if one of these dimensions was greater, a, b, c, d, e, f, then I start here at a. So a plus, let's say c is a very big number. Okay, c is a very big number, and let's say b is very small, smaller than d. So after a, using a greedy algorithm, I will go to d, because I have made b very small, and I have the liberty to make any possible matrix, put any possible values that I want. So after a, I will go to d using a greedy algorithm, and then to c, because it is the, then to e, the only possible value, and then to f. So using a greedy algorithm, my sum would be this. This would be my sum, but this would not be maximum because I have made c a very big number. So if I were to go using this path, that would be the maximum path, and this path cannot be reached using a greedy algorithm. Therefore, in this case, I can create a matrix in which greedy algorithm cannot achieve the maximum value in an array through traversal. So the answer would be yes in this case, and answer would only be yes if at least one of the dimensions it, is greater than 2 and the other one is at least 2. And in my solution for the first one, that is exactly what I'm doing. First, I'm taking in n and m, and then I'm checking if n is greater than 2 and m is at least equal to 2 or greater than 2. Either this or n is at least equal to 2 or greater than 2, and m is greater than 2. And if that is the case, then print yes, otherwise print no. And that is simply lovely, as someone said. Accepted. And yeah, I got it wrong in the first try, but yeah, no points were deducted because no points are deducted in the first try. And let me now read the tutorial for this thing. And yes, okay, my screen was visible. I thought I was like doing stupid things and no one was watching. Greedy. solution. If n and m equal 1, there is only one downward path, so it is trivially greedy and maximal. If both equal to 2, in any path may choose between two neighbors after the first step, clearly moving greedily always leads to a maximum path. Yes. In all other cases, such a grid does exist, assuming n is greater than equal to m. Start with n by m grid filled with ones and modify the top left 2 into 3 subgrid as follows. Okay, fill the whole grid by ones and modify the top left 2 by 3 grid with this. It is easy to verify that in this grid, no greedy path achieves the maximum possible value, because at first it would go from this to this and then here. But if it were to go from here to here to 2 and then to 3 and then to 1, it would be the maximum possible sum, but it cannot be reached by a greedy algorithm. So that is cool. And tourist is back at the fucking top. That is cool. So that one was, I did that question in how much time? How much time? Guess it. I did that in 4 minutes. And yes, I am a pupil now. My rank has increased. Uh, uh, how do I see the time? We're using my standings, but here, yep, right here. 5 minutes. Okay, it took me 5 minutes to do the first question and then 11 minutes to do the second question. Okay, then moving on to the next one, pie shuffling. So this one was pretty cool. Yeah, it took me some time to get to understand this, but this one was cool. And this one was at 1,000 level. Let's see. You are given n piles. So I have n piles, and ith pile contains ai zeros at the top and then bi ones at the bottom. Like in this, is 1 0 at the top and 3 ones at the bottom. And in one operation, I can take the top element of any pile and move it to any position in any pile, including the pile that it was taken from. So I can take this 0. If I have these two piles, then I can take this 0 and pop it out and put it anywhere, in either in this pile or in this pile or any of the piles available. Then I have to calculate the maximum number of operations required to make it so that the ith pile consists of ci zeros on the top and di ones on the bottom. That is the question. Initially, I have ai ones for every ith pile. I have ai ones at the top and ai zeros at the top and bi ones at the bottom. And I want to achieve ci zeros at the top and di ones at the bottom. So how do you do that? It is The answer lies in, it is guaranteed in this line. It is guaranteed that there exists a sequence of operations that transforms the pile into the target state. This means that a solution always exists, which means I can go a little bit on faith. Supposing that I have any pile and I have any pile, and then I will see the number of ones in this pile that I have, and then there is the number of ones that I want to have in this pile at the end. And if I have more ones right now, then I need to have, which means I would have to remove some ones from here. But to remove an element, I have to remove all the elements above it. So there will be a number of zeros at the top, which I have to remove first before removing any one from the bottom. And the number of, so first I will have to just remove all the zeros. So let's say if there were b ai zeros, then I did ai operations to remove all the zeros from the top. And then let's say the difference between the ones that I have and the ones that I need is bi minus di. So I did, to make this file correct, I did ai plus bi minus di operations to make this file correct. And then I go to the next file and I see the same thing. If the number of ones is higher than the number of ones that I need, then I remove all the zeros and the required number of ones and operations, the number of operations, how many they are, I just take them, add them to a running counter. And if the number of ones that I have is lower than the number of ones that I need to have, then I would need to add ones to this pile. But since I know that a solution does exist, then I do not have to care about how the ones will come here. I can just see from the piles that have excess amount of ones, and when they are removing those ones, I can just distribute them in a way that it fulfills the required number of ones in the file which have lower number of ones. So if so when I'm comparing the number of ones, I only care when I have excess number of ones than I need at the end. And when comparing the number of zeros, then if I have more zeros, then I just add in the difference, the number of zeros that I need to remove from that pile to my running counter. And at the end, I just output my running counter, which is here. I have initialized 4 numbers. A is the number of initial number of zeros that I have at the top. B is the initial number of ones that I have at the bottom. C is the target number of zeros that I need at the top, and D is the target number of ones that I need at the bottom. And then I did, what is this? O and Z. I do not need this. This was like I was trying to do something else, and this is still here for some reason. And then I initialize the number of operations to 0. After that, I go in, and for every pile, I take in A, B, C, D, and then I see is the number of ones that I have right now, which is B, is it greater than the number of ones that I need after all the operations are done? And if that is true, then to op okay, I see a problem. No, not in my solution, but in my web. After that, I add to my number of operations all the number of zeros that I have at the top initially, that is A, plus the number of ones that I have to remove. Else, if that is not the case, then I see, do I have excess number of zeros at the top? If I do, then I just add the extra number of zeros to my operations, and at the end I output the number of operations. And the problem that I saw in my vim is that instead of tab, I have spaces, which is hurtful to my brain. Why is my cursor like in the middle? I must have done something from here. Relative number, clipboard, cursor line, UI. Tab stop 8, that is okay, expand the tab. I do not need to expand the tab. Now it should be cool, I guess. Yeah, now it is cool. Or maybe not. I need to rerun them. Yes, now it is cool. Now I do have actually tabs. Not here, but here I do. That is cool. And yeah, I did that in first try. That is cool. Hello, Azan on track. And SK Samir, what are you doing, bro? I am trying to analyze yesterday's contest on code forces. CF means code forces. And let's see, Manhattan pairs. This I was unable to do. 23,000 people registered for this contest, and only 4,000 were able to do this question. Let's see. And I'm also hoping after this, after reading the tutorial editorial for this question, I would also like to see get into this. I didn't read this question, so I would like to read this and try to solve it on my own. And that's like trying to expand my capabilities, I guess. And I also want to see what did tourist wrote for his solution. Contests. This one. Okay, this is okay. And this is my profile. Uh, uh, Here, enter standings, tourist, contest. Shit, can I see? Yes, I can see the solutions. Rank number one. That is cool. Okay, he did the first one in first. Oh yeah, starting from here, he did the first one in first try. And how much time did he take to do the? Okay, he did the first one in 0 minutes. That is cool. The second one in 3 minutes. Then the third one in 3 minutes. Wait, is it took him 1 hour to do D? Okay. Uh, Shit. Okay. Okay, so he did the first three in 6 minutes total, and then to do the remaining questions, it took him 1 hour 42 minutes. That is crazy. Shit. That is actually fucking crazy. Okay, and moving on to what he wrote for his solution. This is fucking crazy that I can like literally see what he wrote. And I think the way that he is submitting his code is crazy. Like why is this thing here? Mm, is he using something to submit his code faster? Eh, Here is the solution. Starting from here, this much. If n equal to 1 or m equal to 1 or n and m equal to 2, then output no. Otherwise, yeah, that is similar to what I wrote. Yeah, so we have like same thought process, me and tourist. And here, int I taken n is the number of piles, yes, the number of piles taken n, and n64 answer equals 0. Go tell n taken abcd, yes, and if b is less than or equal to d, that is I need more than what is right now, then add c minus d, maximum of either 0. B and D are the number of ones at the bottom, and if I need more ones or equal ones that I have right now, then I am adding to the answer maximum of 0 or a minus c. A minus c is the number of zeros that I need to remove from the top. Okay, I'm just caring about the number of zeros that I need to remove from the top. Okay, else if that is not the case, if I need to remove some ones, then I add a, that is I remove all the zeros, and then I add maximum of this. B minus d is the number of ones that I need to remove. So yeah, it is similar. It is similar. And now moving on to the question that I was unable to do. Hey, how you doing, man? I am doing amazing. How are you doing? You have been here from the first day, which is crazy. So this much question is just this much, and I am given a bunch of points, and the number of points, that is n. N is even, so I have an even number of points. So I need to create pairs of those points. That is, let's say, here I was explaining to a friend of mine this thing. So if these are my points, then I need to create pairs between all the points. These are my pairs. This is one pair, this is one pair, this is one pair, this is one pair, this is like that. Create pairs between all the points, and the distance between the points of every pair is something, and I add the total distance, and I need to pair these points in a way that the total distance is maximum, and at the end I need to return the pairs that would be created to get that total distance. And I thought about this for like more than an hour, for like 2 hours or 3 hours, but I was unable to solve this. Now we will be going to the tutorial to see how this can be solved. Manhattan distance solution. Okay, that is crazy. Crazy solution. Let's begin by considering the 1D version of the problem. If the problem is 1D, in one dimension, the optimal strategy is to pair the smallest n by two values with the largest n by two values. The smallest half values with the largest half values. Yes, 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 makes sense. Now let's move to 2D case. Wait, but can I do that in any order? If we are in one-dimensional plane like this, and I have a bunch of points, let's say here, 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 and here, how do I pair them up? Uh, okay, these are the smaller points, these are the larger. So can I pair them up in any way? Like if this is one pair and this is another pair and this is the third pair, then I'm getting this distance once, this distance twice, this distance three times, this distance twice, and this distance one. And if I were to change the points, let's say I make new pairs of these 2 points, these 2 points, and these 2 points. Let me do that on here. This is it. These are the points. If I do this and I create pairs like this, these two are connected. This is the middle line. These two form one pair, and these two make another pair. Then I am getting this distance one time, this distance two times, this distance three times, this distance two times, and this distance one time. It is same in both the cases. 1, 2, 3, 2, 1. So I can create any point. Okay, that is cool. So if that is the case, then I just need to find the middle point, middle value, and I can create pairs any way that I want. That is cool. That would be the solution in one dimension. But we are in 2 dimensions. In one dimension, that would be the solution. Now let's move to 2D case. In 2D case, I could have a point here, another point here, 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 any which way. And would it be cool? Wait, if that is the case, if let's say now we are in two-dimensional plane and I have points spread around everywhere, let's say. Let's say like this. So there would always exist a line in this dimension which should divide the points in left and in right, and there would always exist a line in this dimension that would divide all the points from top to bottom, and there would of course could be some points on the line itself. Okay, so I guess I need I need to make connections between points of this plane and this plane, and connection between points in this plane and in this plane, and the points on the lines. No, let me read. But if I do this, then I would be getting, if I do like this thing which I'm talking about, then if I connect this point with this, then I would be getting the maximum distance in this way and the distance in this dimension also on both the axes. And if I were to connect this point with this, then I would be crossing this axis also and this axis also in this way. And about the points which are on the middle, all the points which are either on this line and on this plane, and I'm not including this line, just this line and this plane, they can be connected with the points which are on this line. No, no, no. Which are, well, of course, on this plane and on this line. This line and this line is not included. This line and that line, but that we take in, and the points on this line then would be connected with the points on this line. Hmm. Let's read the solution. Now let's move to 2D case. The Manhattan distance is the independent sum of the coordinates from the x-axis and the y coordinates. Therefore, we find a matching that is optimal independent for both x-axis and y coordinates. It will also be optimal in 2D. To achieve this, partition the set of points in two different ways. Let xl and xr be the sets of points with the smallest and largest half x coordinates and largest, yeah, smallest and largest half x coordinates, half n by 2 coordinates, and yl and yr are the same in the y-axis. A pairing will be optimal if in both dimensions. A pairing will be optimal in both dimensions if each point in XL is paired with a point in Y in XR, and each point in while is paired with a point in YR. That is true. But what about the points which are on a line, like this point and this point? This and this point. This would be on XL, and this, where would this point be? Can a point like actually occur on line? If a point is on the line, in which group should I add that point? If a point is on, let's say, x-axis, like on y-axis in this case, this point, these two points are on the y-axis. So do I add them in the left group or the right group of y-axis? I guess that might not, that would could be a fair question. Okay, if I have this, 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 and this as point, then the middle line horizontally would be this, and vertically would be this, vertically would be this, horizontally would be this, and XL would include this point. Let's call this 1, 2, 3, 4. This would include, XL would include 1, and how about 2 and 3? Where will they go? And XR would definitely include point number 4. But where will 2 and 3 go? And YL will include 3, and YR would include, of course, 2. Now, in terms of Y, where will the points which are on the line go? I think I can add them in both the groups. I can, since here 2 and 3 are here, I can add 2 here and 3 also here, and then 2 here, and then 3 also can come here. And in this case, I can add 1 and 4. 1, 4, and 1, 4. Now I begin from XL and find a point in YR, XR, which is not in XL. So that would include, let's say I find 1 and 4, and then I see R1 and 4 in different pairs here in X and Y. And if I see that I can find 1 in one place and 4 in the other, then I can make 1 and 4 into one pair. Okay, then I can just remove them. 1 and 4, 1 and 4, remove 1 and 4, remove 1 and 4, remove 1 and 4, and removing them is like I will have an array in which, in place of 1, I will have 1 and 2 and 3. I would have 0, representing that no pair has been formed for them. So 1 and 4 is one pair. Then I go and see the next element, and I see find a different element in XR, and I see it is 3. So I choose the pair 2 and 3, and I move on to this, and I find either 2 or 3 in YL. And on finding 1, I will look for the other. I will look for the other in YR, and if I do find 1, I will make that another pair. 2 3, and that would be correct. It would be this pair and this pair. I would get this distance and this distance, and that does make sense. Let's see. To satisfy both the conditions simultaneously, each point L L find common points in Excel, while with a point and XR and YR. Each point in this with a point in this to satisfy both conditions. Yeah, this and this. Yes. Its A, B, C, D denote the sizes of these four groups respectively. Note that they are disjoint. Then disjoint, that is, they do not have any commonality. Then we have A, B, C, D. Then we have respectively A plus C. A is XL and B is XR and C is YL and D is YR. So because size of XL equal to size of XR. Yeah, half. Size of XL equals size of XR. So this is XL, this is XR, and this is YL, and this is YR, and this is XL, this is XR, this is YL, this is YR. Adding these equations up yields A equals B and C equals C. So much a pairing is always possible. So such a pairing is always possible. Adding these two up means size of A equals size of B and size of C equals size of D. Okay, I think I can implement this question. Stop time pass. In 2D we can get more than two variable. Is it possible? More than two variables? What does that mean? Keep it up. You have a nice logic. Plus your communication will also improve by doing these types of sessions. Yes, that is what I'm hoping for. Ari Joshi, I got 1800 performance yesterday by solving 3. Observation that I got for C was when we sort on X and divide it into two groups. First will have half of the smaller elements and the second will have the other half. You will always get total X sum as same. Yes, yes, we did that experiment in 1D. When you choose any two pairs from points from different groups. Yes, that is what we did in 1D. And now I need to do this thing, implement this solution, making a pair, right? And after that, after making a pair, hmm, maybe I can take the average value of X and the average value of Y. And yes, I think I can take the average value of X and average value of Y if if I am working on two dimension and I always have a pair of points, let's say this and this, then the average would be here. And then let's say I add 2 points right here, then the average would be here. Shit. No, shit, this is it. Yeah, the average would not work. How do I find the middle value? Median, right? Yeah, shit. How to find median? To find median, uh, add plus plus plus. Do I actually have to sort them? I think there should be some other way method to find the middle point without sorting. I need to find this, but average would give me something around, would actually average give me something around here. Let me work with like concrete examples. If I have numbers 1, 2, 3, and 100, then the average would be 106 divided by 4, and no, that would not work. That would not work. It would give me a bigger number, 25, 21. It would give me 21, but that is not, no, it would give me 26. That is not what I want. I would like to have I would like to have 2 in this. So I'm looking for median. How to, this shitty, how to calculate median of a bunch of numbers. Shit. If the number of values is odd, the median is the middle value. If the number of, so I will have to sort it. If this is sorted without sorting, like median of array is 4 algorithms, like, because if I were to sort these elements on the basis of x, then I would also have to sort them based on their y index, and I do not want to sort this twice. Let's go with that. Like, I am unable to think of any efficient algorithm, so let's first go with that, and then we will look later. Sort, and I do have even number of numbers, so sort a, all a, and this is my function pi a, pi first, pi second, return f dot first smaller than f dot s dot second. It will be sorted, and after sorting I will go to the middle 2 elements and find their average. X mid equals a bracket n by 2, uh, uh, if n is 2, a n by, if n is 4, then I need index 1 and 2, and to get the first I have to subtract n minus 1, this thing, plus a n minus 1 divided by 2, and add 1 to that thing, plus 1. And what is the problem with that? And divided by 2. This plus this, and divide. Okay, a dot first dot first first. So I have this, the middle value in x, and int y mid. Before that I will have to sort them again. Sort it again. Y mid is somewhat similar formula. to this. Second, this y x mid and y mid. Okay, so I have a number which I can use to compare the values x mid and y mid, and now my array is sorted in terms of y, smallest y with the greatest y. So okay, I can either do this or that, find a pair, and okay, for int I equals 0, I less than n by 2, I plus plus, and shit, after sorting this I lost the original order that I had. Yes, fuck, I lost the original order that I had. Shit, how do you like actually implement this thing? Because at the end I need to return this thing, and to return this I need to preserve the order, and thus I cannot simply sort them. I cannot simply sort the array. No, I cannot sort the array. I can make a copy and sort that copy. Vector pi uh, b equals a. I guess this makes a copy, and then I can sort, instead of a, I can sort b, and work with b. Right, that is cool. Now I also have the original order and I have a sorted version. Now my 2 points would be the first point in the B array and the last point in the B array. So int f equals, not int f, auto f equals no. Yeah, that is cool. I would also need another array vector of integers, say done, of size n, and initially everything is 0 or not integer. Vector of boolean would be cool, and everything initially is false, and false means that the current pair has been done. So initially everything is false, and then here I have b dot b bracket 0. That is the first one, not 0, b bracket I, and I need to go from the start, go from the end, and go down. So int j equals n minus 1, right, and go down while j greater than, if n is 4, then I can go from 3 to 2. So less than greater to n by 2, uh, greater than equal to n by 2, and then, and also one more thing, Also that not done J. J is not done yet. If that is true, then I have I and J as my things, as the coordinates, and now I need to find them if they are on the opposite sides, right? So if I know that they are on the opposite sides on the y-axis, now I need to find if they are on the opposite sides in the x-axis. For that, if I can remove this, I do not have to do this. If bi dot first is lower lower than or even equal to x mid, and bj dot first is greater than x mid, either this case, or we have bi dot first is greater than x mid. It would even be equal to, yeah, they would both not be equal. Even if they are equal, then I think that does not matter. This thing and this thing, and bj dot first is in that case lower than or equal to x mid. If either one of those condition is true, then we are good to go. You can do done I equals to done j equals true. That is one thing, and I can see out this pair. I can see out I dot shit. I messed up. How do I know where this point is? Where this point was in the original order? I would have to traverse through the A array and find their original index. Shit. I need to find their original index, but how do I do that? I have the points. How do I find their original index, which was given to me? Unordered map or traversing? Is traversing the only way? Let's see first. Else, if that is not the point, then just do j minus minus. Like, look at the next point. Shit. So I have the points. Points are I and j, but I need to find their original index. That is the problem now. And I do not want to go through the A array every time that I do that. So instead of storing them in a pair, I could store them in a vector, in a vector of vectors containing three elements, because I would need their original pair, which would take two integers and a value to indicate their original value. Static on the heap. Okay, I think instead of this, I can do int this size 3, if this possible. And what does this mean? What is the type of a? Long 3. That is cool. And then a cin ai dot ai 0 ai 1 and ai 2 equals I, or more like I plus 1. If that is the case, then I don't need B, and to sort them, I will sort A itself, and this does not return me a pair. This returns me an int, this of size 3 for shit. No, no, not it's cool. Not it's cool. Int size 3 and compare their first. That would be 0, 0, 0. Cool. Replace this with A. Replace this with, go to the middle element and find its first, which is 0. uh, dt divide, find its 0. B, replace this with A. That is cool. And now replace this with 1, this with 1, and replace this with Y, and this becomes size. That is the size. Okay. And this is also 1. Okay. After that, this becomes 1, 0. This is A. This is A 0. This is A, and this is A 0. This is A. This is A 0. And yes, output just AI 2, that is the index, A J 2. Then the next line, that should work or not. Shit. I think this is the problem, the way that I'm doing this thing. If I do this and instead here create int AA array equals new of 1 to I. Can I do this? No, I cannot. What is the syntax? 1 to I. I cannot do this. Int array initializer must be an initializer list. Must be an initializer. Okay. How to get an array of a specific size on the heap in C++. See, so is it mostly maths, right? Competitive programming. Not mostly, it is more like logic building. A lot of logic building is there. Yeah, new operator. That is what I was hoping for. New int and size. Okay. My bad. Must be an initializer. List my array. My array is a pointer. Okay, now we are cool. And this and this. How about this? Segmentation fault. Fuck. Hmm. Segmentation fault. Shit. Clang plus plus C Manhattan dot out dot slash out and sample case. Let's go with this one. I have only one test case, which is this, and I'm facing segmentation fault. But where am I facing segmentation fault? Dot slash out 1 4 1 space 1 right there. Okay, right here, segmentation fault. Oh, yes, shit, yes, yeah, my bad. This is A, and this is A, and this is A, and then A I equals A. Wrong answer. That is better than segmentation fault. Is it wrong answer? Compile again. This 1 4 1 1 3 0 4 2 3 4. Okay, I am getting no answer. That is cool. Otherwise, J minus minus. Okay. Let's see. See out X mid and then a space, then Y mid, and then like let's see, and 4 2 minus 2, 4 and 2 are X mid and Y mid in the first cases. In the first case, I have at numbers. Wait, Y is 4 X mid. I have numbers at 1 3 4 3. Then X mid should be at 3, right? Yes, X mid should be at 3, because on the left I will have 1 and on the right I would have 4, and I would have 3 and 3 on the line itself. X mid is wrong and Y mid is 2, which is also wrong. Y mid, shit, what would be Y mid in this case? 0 1 2 3. If I make this float, then it would be a bit better. No, it is fine. I think it is fine, like as it is. So 2 is fine. I have 2 points on the left and 1 on the point and 1 on the right. This is wrong. Y is wrong. Like this 4 is wrong. This X. This is not supposed to be 4. I am sorting. Sorting. Cout A0 0 space A0 1 space A space A0 2 and then a new line, and the same for this, and this make this 2, and now let's see. In the first place I have this 1 3 3. Yeah, so that is cool, that is cool. Let's also go all the other way. Find 2, replace 3. Let's see now. Yeah, it is cool. 1 3 3 3 4. So I should get here after sorting n is equal to 4. So 4 minus 1 is 3 and 3 divided by 2 is 1. So 1 1, right? 1, and at 1's place the value is 3, and the next one that I want is 2, which is 2, n minus 1. N is 4, n minus 1 is 3, 3 divided by 2 is 1, and 1 plus 1 is 2, who's at 0. Put shit. If I do this, it would be better. How about now? Now I have 3 here and 1 here. That is cool. That is cool. Let's see. It says wrong answer. Am I not getting any answer? Shit, I am not getting any answer. But 3 is correct and 1 is also fine. 3 here, 3 is correct and 1 is fine. And in the next one, I'm getting -1 and -1 for x and y both. 3, I'm getting -1, -1, that is fine. 2, 2, -1 would be fine. 1 on the left. No, both of these are on the right. Both of these are on the left. This is on the right, this is on the left. So -1 is fine. And here, -1, this is on the line, does not count. I can count it in any position. This is on the right. So 1 disbalance. This is on the left. Cool. 2 points on the left, on the right, 2 points on the left, 1 on the left, 1 on the right, and 1 point on the left. There is a disbalance, but I can count -1 on the right, which should fix the disbalance. So -1 is cool. So where am I going wrong? This is sorted. I is going only halfway. Yes, it is only going halfway. J is the last element, n-1, while j is greater than equal to n-2, n by 2. Okay, let's simulate this thing for this one. For this. Oh, for this, this is my thing, and I have x mid equal to what, 3, and y mid equal to 1, right? That is what I have. Yes, 3 and 1. And then I begin with the smallest on the y-axis, which is this, and largest on the y-axis, which is this element. And then I see its x-axis element. Okay, here. Now I am checking this condition, which is this thing less than equal to 0? 0 is x, its x coordinate of ith and jth value. This is ith, this is jth, and this and this. Is this thing true? Is this thing either lower than or equal to 3? It is lower than or equal to 3. And is this thing either greater than or equal to 3? Yes, that is true. So I should have included this pair here. And okay, I am stupid. Not done. Now it outputs 2475. That is very cryptic. Shit, 24. What is that supposed to be? 2475. Mm-hmm. J is not done. Fuck. Clang plus plus. Run it. 141130424. I get 24. 24 is not correct. 24 in this case, if I go with 2 and 4, the original answer is 2, 3, and 1, 4. But if I go with 1, 4, the original answer, then the Manhattan total Manhattan distance would be 2 plus 3, that is 5. 5 plus 1, 6 plus 2, 7, 8. 8 would be the total Manhattan distance for the original answer, and the answer that I am giving, the distance would be 3, 1, 2, 2 plus 1. I give 2 and 4, right? 2 and 2 and 4. 2 and 4. So 0 plus 4, 4 plus 1, 5 plus 3, 8. And 8 is the answer that I'm getting, and I forgot already the answer that was original. 3 plus 2, 3 plus 2, 5, 5 plus 3, 8. Shit. So this is correct. This is correct. My answer is correct. Why am I not printing the second pair? Because not done. J greater than equal to 2, n is 4. I became that, and I go from the start. This, okay, Yeah, shit. Yes. Yes, shit. This condition has shouldn't be here. This should be around here. This or this and and not done J. Now, how about it? 2 4 2 3 is crazy. 2 3 is crazy. I am getting the same number a multiple number of times. Shit. Is okay. Okay, if I do this, then I break. However, now I'm getting a pair less. 2 4 1 3. That is correct. 7 5 is cool. 6 2 might not be cool. 10 1 might also not be cool. This is and one pair I didn't even get. 1 2 3 is not there. 4 is not there. 3, where is 4 in the original answer? 4 is there. 3 4. I didn't get 3 and 4. Why was that? The third and the fourth pair. I is going forward. That is correct. And for every pair on the left, I go to the right and make reduce J, reduce J. If J, while this, if J does come to the end and the above condition is not true, hmm, shit, no, then this thing. Each point should to satisfy both conditions simultaneously. Each point this is paired with a point in this, and each point in this is paired with a point in this. Yes, I can maybe create a set of points after sorting them that would make 4 sets of n by 2 size. One set for this, one set for this, and one set for this, one set for this. Yeah, it does say set. And then each point, this, or this. I'll, so for every point in Excel, I will traverse through every point in RL and see that are those points in different pairs of YL and YR. If they are, then I go on. So I can change this and create a set of shit set of integer pointer called XL of size n by 2. No matching instructor for the can I not create a set of a certain size, I guess. And one for right, one for Y, one for Y right. And after sorting, the first n points go onto the left set. So for int I equals 0, repeat let's I 0 till n, and if I lower than n n by 2, then xl dot add push back push back this AI November push back and vector of long int and set long pointer, and I am pushing back a pointer. Address November named pushwagon excel dot insert. Okay, insert AI. That should work. Else xr dot insert AI. Okay, do that, and then after sorting this, I will n if I less than n by 2, n by 2, do the same thing for this. Instead, make this y, make this y. Now I have two pairs, x and y, and I will traverse through for auto x and xl uh, for every pair in x, for auto, okay, this xl, small xl, small xr, and xr for every pair in xr. I have now two pairs, xl and xr, left pair and right pair, and I need to see if they are in the opposite sides. So if yl dot has count xl, it would return 1 if it is there and 0 if it is not. So if it is on y's left, if y left has xl and y right has x right, either this thing, or y left has xr and y right has x left, if any one of these is true. And also I need to like my done array done, yeah, done. If xr, if not done, wait, and if not done bracket xr 2, only then do this, yeah, only then do this, check this, otherwise move on. And if any of these conditions are true, then make both of them done xl 2 equal turn xr 2 equal to Gundan equal true, and see out xl 2 with a space xl xr 2. Okay, I think I messed up. Yeah, this is the wrong answer. 1 3. Okay, 2413. That is do that is like okay. And shit, I have to compare this. Okay, 2413 is correct for the first one, and for the second I have to check. 109 is exactly there. I do not have to add and check that. That 85 I have to add, 72 I have to add, 46 is there, and 31 I have to add. So 317285, which is in this 3 1 this 7. Okay, for 3 1 distance is 1, 2 2 plus 2 plus 7, this is 2, and 7 1 2 3 7 7, the distance is 6 plus 3 9 9 plus original 2, that is 11, and after 11 3 1 7 2 8 5 8 5 11 11, and distance for 8 5 1 2 3 4 5, right, 5 and 8 is this, is it 5 1 2 3 4 5 and 6 7 8, distance between this and original was 11. So 11 plus 4 15 plus 4 19. So my output says 19. Okay, 19 is what my answer says. And for the original one, the pairs that differ are 8 1 8 1 7 5 2 3 8 1 7 5 2 3. Okay, 8 1 1 is this, 8 is this and this, 1 plus 3 4 4 4 4 plus 7 5 3 4 5 5 6 7. So 4 plus distance between these two, this is 4 plus 6 10, 10 plus 4 14 14, and the last pair was 2 3 4, 14 plus 2 3, and the distance between these two has to be 5 for my answer to be correct. 1 and plus 4. Fuck, that is correct. That is actually fucking correct. So let me try and submit this for problem number 3, Manhattan pairs. On test 5, out of bounds. Which line? How is a syntactical mistake, because the second index is one indexed instead of zero indexed, because when I was storing them, I stored them by adding one to it. So copy this, go back, submit, and hopefully this works. Try similar problem, bro. At your rating level, C would be 1600. It would be difficult for you. I am trying still. You are wasting a lot of time on one problem, which you is way beyond your level. I decide my own level. What is your maximum rating? Mine is 1200. 1200. And so how many did you do last year, bro? What's the point? You literally saw the full solution and solved. How is it still wrong? Why is it giving 3 out twice? I just changed that one thing. Okay, both of them, I made them true. Okay, yes, yes, yes. Here also, here also. And any other point I am doing too? No. Or instead of this, I guess I can do n plus one here, and I can remove this. I can remove this. I can remove this. 1323, that is correct. And 1095872461, that is also correct. Let's see. Test number 5. Okay, 8. Okay, it is not optimal, but it is at least correct. And don't give so negative comments, guys. If you are better than or here watching him, yes. And sorry, bro, just don't want him to repeat the mistake that I did. Uh, like, I like to play with questions, and that is cool, playing with things. Shit. Time limit exceeded. And shit, I was hoping that after solving the third one, I would go on to do traffic lights, fourth question. But nah, time limit exceeded. So at least my solution is correct. Now I guess I have worked long enough on this question, and I can move on and see what did tourist did in his submission. That would be cool, seeing his solution. He's a smart guy, Gennady Korotkovich. So this third, it took him 6 minutes to do this question. 3 minutes to do this question. It's crazy. Yeah, this much is his solution. Int n, okay, n, and two vectors. Okay, take in xi and yi. Okay, take them separately and order Mm-hmm. This much I understand. Vector, create another vector, integer, iota, order dot begin, order dot end, and 0. Iota, shit, I have seen this function. Integer, CPP reference, CPP reference. Uh, Fills the range first and last with sequentially increasing values, starting with value and repeatedly evaluating value plus plus. Okay, evaluating operation. Some value returns the incremented value. Repeat until last is reached. Okay, so this function, this is an iterator starting and this is an iterator ending. So this fills order from 0 to n minus 1, starting from the start and end. Okay, and then sort these depending on taking a reference of numbers I and j. He could have done without this and sorting them would depend on their x value and then okay, begin plus. So now x, so now order is sorted depending on that. Shit, this is cool, this is cool. I think I understand this. And this, he's then beginning, he's then reordering the second half. Okay, and then he is simply outputting from 0 to n minus 1. I is I and I plus 1. So because it is 0 next, and order I 0 because yes, he began with 0 I plus 1, and then the second one is I minus 1 minus I. Yes, yes, that would be correct. And since I have half, shit, that is cool. That is cool. Let's say I initially had this many points, right? This represents points. This represents points, and I have sorted them. There are in total 8 points, and let's say after sorting them, depending on their x-axis, this is what I have. These points right here have their x value is lower than all the points on this side. Okay, and then I am beginning to sort this half array into two smaller halves, this and this and this, and here x is smaller than the x of values here, and on these y is lower here. Here the points have their y value lower than the points here, and same thing in this subdivision. The y value of these points is lower than the y value on these points, and then you begin to iterate starting from the first element, and with that you pair the last element. So if you do that, I think you should iterate with this. You should pair this with this and this with this and so on like that, and then beginning from here you pair this with this and this with this. But he has not done that. I plus 1, and then he is going to the last. He is going to the last. He is pairing this one with this. So it is guaranteed to fulfill this condition, but how does it guarantee to fulfill this y condition? Because this y might be smaller than this y. These 2 points, this one and this one, are guaranteed to be on the opposite sides on the x-axis. And how do you guarantee them being on the opposite sides on the y-axis? Hmm. Do you guarantee them being on the opposite sides on the y-axis? Their x-axis condition is true, but y-axis, why? Cause this. Is he's sorting the first half ij depending on their y condition, and then the second half depending on their y, and then he's traversing from the start with the end. He's pairing the starting element with the ending element. Hmm. Hmm. Okay, I get everything else in this code except this. Why does pairing the first number with the last number work? Why does that work? Could this give an error? Okay. So their X condition is true. That is not giving any error. But the doubt is, why would this thing hold if this is my method of iteration starting from the first and the last? So this thing sorting the first half and the second half depending on their y would, let's say, let's say I have a single line y-axis and I have a bunch of points, right? Like randomly scattered points, an even number of points. So after doing this first um, after doing this first sorting depending on the x-axis, this one, these points will be randomly distributed in two groups. And let's say the first group includes this point, this point, this 1 2 3 4 5. Okay, I need one more point. Hmm, let's see this. Okay, first group contains 1 2 3 4 5 points, and the second group contains 1 2 3 4 5, the remaining 5 points. Then I will have two medians. uh, I will have two medians. One would be here, dividing these red points into, and the other would be here, dividing these 2 points, these green points, in two pairs. And when I iterate, I will go from here, one from the last. So yeah, this point, this, 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 and this, they belong to one place, right? They belong to one group, and then this point, this point, this point, this point, and this, they belong to the next group. So when I'm iterating, I start with this one point and I choose the one on to the rightmost of this other group. Hmm. Would would there be a condition in which this would be false, this would be wrong? Then I go with this, choose this point, and from the right, I choose this point. Then I go and choose this point, and the official one, two line would be here. These points should be paired with these points, and when I choose this, I pair from the right this point, and when I go with this from the right, I choose this, and then when I go with the next green, which is this, I choose from the right this, and when I go with this green, I choose from the right. Shit, that is working, but why is that working? It feels like I'm just like at the cusp of understanding why this is working. So this line is dividing the points in some number, and let's say there are in total 5 green points and 5 red points, which there actually are, and this line has in total 5 points on the left and 5 points on the right, and among those 5 points, two are green here and three green are here, and three red are here and two red are here. So fuck yes, when I choose any of these green points, these two will be paired with these two, and when I choose these 3 points, these three will be paired with these three, and my condition would hold. Shit, that is cool. That is cool. That is cool. My condition would hold in that case also. That is cool. What's your rating? My rating is 12, 90 something. What is my rating? 1200 something, or maybe 1100. Okay, now I will implement the solution. 1273. 1273. Now, to implementing the solution, can remove everything, cn, and then vector sx and y, size n, I0, n, cnxi, y, I, and then pi, order, size n, and iota, order, all, order, starting from 0, then sort, all, order with this. It will have integer a and b, and return depending on x a smaller than x b, That is why you needed this. Okay. Should I read about this? Why you use this ampersand in the middle? Uh, When I use ampersand in the middle, then this function which I am passing on to sort will be given as a reference, not as a copy. Because if this function were given to sort as a copy, it would not have access to x and y which are here. But if it is given as a reference, then it is defined in this scope which contains x and y, and this function would still have access to x and y. That's cool. And then from order dot begin to order dot begin plus n by 2, maybe like a little bit of this. No, order plus n by 2 a b, this thing, and this on y, and here order dot begin plus n by is n by 2 fine, to order dot end, fx replace with y, and I0 n c out order I plus 1 because it is 0 indexed, order n minus 1 minus I from the end, and this should work. To up, my bad. Plus 1. Now it should be correct. Before this is 10 9 8 2. This seems correct. And submit. Gennady Korotkovich. Time limit exceeded. Submit. Let's see. 3 viewers. That is cool, and that is fucking accepted. Cool. It is accepted. And my solution took 171 milliseconds. And how much time did tourist's solution took? I would guess about the same because I literally copied his solution. He's a very social person. Solved. His solution took 0.09 seconds, about the same. So what are the things that I didn't know about? Yes, this thing. To take x and y in different arrays instead of storing them as a pair, I can do this. Okay. And then take them in and then order and divide that order in two ways in this sophisticated way. And this iota function, I didn't know about this. That is cool. That is cool. Those are the things that I didn't know about. The fact that I could take them separately and order and sort order depending on x and y, which is fucking cool. sort their index, which would be equivalent. Yes, which means instead of okay, yes. So the thing that I can take from this is that instead of first of all taking in pairs, I can take in the coordinates in two vectors separately for x and y. And then instead of sorting those supposedly taken in pairs, I can create another order and sort that instead of sorting the pairs themselves and sort their indexes, and that would depend on the values of the coordinate. Okay, that is the thing that I get from this. Okay, instead of sorting the pairs, I can sort their indexes depending, and sorting them would require me giving in a reference function. Okay, that is cool. That is cool. Now, what I want to do is at least understand or do the D level problem. See the D level problem. Shit, my logo right here. D, traffic lights. You are given a simple, but how much time has it been? 2 hours, 1 minute. I have 30 minutes. At least 30 minutes. You are given a simple unidirected connected graph of n vertices and m edges. Okay, I want to at least understand this question. You are given a simple unidirected connected graph of n vertices and m edges. Unidirected, unidirected is the edges point from one to the other, but not from the other to the back. Unidirected graphs of n vertices and m edges. Okay, there is a token in vertex 1. We consider, okay, there is a token in vertex 1. We consider the initial time to be at 0 seconds. We consider the initial time to be at 0 seconds. Okay, after t seconds, if the token is in vertex u, okay, initially it is in vertex 1, and after t seconds, if it is in vertex u, you must do exactly one of the following: either wait 1 second or move the token through the this edge of u, which takes 1 second. Okay, so either I wait for 1 second or I move the token to this edge. And what is this? Taking mod of time with the degree of u. Degree of u means degree of u simply means how many edges is u connected to. So taking mod with that would be cool. Would just mean I get one of the edges at random. But why am I adding one to that? Because zero indexed, because it is first indexed. Okay, the order of edges of a vertex is the order that they appear in the input. Okay, calculate the minimum time required to move token 1 token from index 1 to vertex n, and the minimum time spent waiting that can be achieved while minimizing the total time, and the minimum time spent waiting that can be achieved while minimizing the total time. Okay. Mm-hmm. Okay, I understand the question at least. That is cool. I understand the question, and now I will try to illustrate what I understand. I have a bunch of edges. No, no, these are not edges. These are vertices, and they are connected unidirectionally like this. Like this. Like this, let's say. And let's say this is my initial starting edge. Starting edge. This is my final edge, and I have a token on this one, and I want it to go to this one. Right, so I will have path, a lot of paths. One path that takes me from here to here. I need to just find the shortest path, I think. I can do that using Dijkstra algorithm. So going from here to here and then directly here. hmm Okay, that is one thing. And that is cool. So, but if I want to go from this vertex to this vertex, I need to have this thing true. This mod has to point to this vertex. And to make that possible, at worst time, I would have to wait order of this -1 time, -1 seconds. Yes. So I think in the first time, I wait for 1 second and then I go here. And now time is 2 seconds. And this one has two vertices, this at index 1 and this at index 2. And so I make wait for one more second, time becomes 3, and 3 mod 2 gives me this one. So I go here and completed. This would not work with simple Dijkstra because if I want to go from one edge, one vertex to the another to the next, then I might have to wait for some time. And instead of waiting, I could either take another path in which I can go immediately, and from that maybe immediately go to someplace else and immediately go to someplace else. So I do not have to wait and I can immediately go from here to the end, from the start to the end. But I guess at every vertex, I have two choices. First of all, I will follow the Dijkstra algorithm and find the shortest path. And then at every edge, at every vertex, I have two options, either to follow the Dijkstra algorithm from that point on, that might involve waiting for some time, either that or go to the vertex that I can get to the fastest and from there follow the Dijkstra algorithm. I guess that is it. And bro, how can I start CP? You just go and start solving questions. That is what I did. You can start solving questions on this TLE eliminators CP sheet. This is what I have been solving on the stream. I'm at 1100 level right now. You can go and solve this. And yes, that would be it for the analysis of this thing. But now I want to do one thing. Yesterday I did one question from @coders, one dynamic programming question from @coders, this one. And my solution gave some error. Where can I don't like, I'm not even familiar with @coders interface, where tourist is number one here also. Like, shit. Contest home English. My name is Walrus. Say recent contests. So there was this contest. Click there. There were questions till G. Okay, scoring is very low. This was a beginner contest because okay. JPRS, Japan Resource System. How do I see the questions? Tasks. Okay, questions are called tasks here. Okay, if I click on one task, I see the question and I can submit the question below. That is cool. Clarifications, if there are any clarifications, they come here. I could also submit from here, selecting your question. Okay, results. Okay, my submissions are all submissions. Okay, these people submitted their questions. Okay, these are all submissions. Then standings. Okay, these are the standings. They are the same way as they are in code forces. Okay, virtual standings. What is that? I don't know. Custom text. I could write. What is custom text? Okay, if I want to do something here, I guess. Uh, J, no, Henry David. Oh, Henry David Thoreau. And I would also have to include the library. Include IO stream. Let's see. Run and waiting for execution. Henry David Thoreau. Okay. So if I want to do something, I can run my code here. That is cool. Editorial. Editorial for these. I can click here and I will be taken to the question, not the editorial. There is no editorial yet. Okay. And if I want to discuss, I can discuss at coders competition on code forces. Okay. Japanese edition. Shit. There is an editorial for Japanese edition. Click here. English. Okay. So how do I submit? We're given integers this of length n and it is a determine whether x is contained in a. Okay, shit. That is very hard. I can submit right here. Include IO stream and main and also include vector. No, I don't need a vector. I do not need to store. What is the format that I'm getting it in? First the number and then okay, int n cd in n and then the numbers for int I equals 0, I less than n, I plus plus. Okay, I will have to store the array for which I would need a vector. Include vector and here initialize a vector of integers. Initialize a vector of integers, call it a of size n. And shit, this thing does not have vim. That is crazy. After this, cd cm ai and then end x cm x for and I equals 0, I less than n, I plus plus. Now, if at any point ai equals x, then cout yes with a new line and break and also let's say x equals -1, right? Yes. And now here if x not equal -1, then cout no submit. Thank you. You're welcome. WJ. Waiting for just CE. CE is wrong detail. Okay, what is compiler error? This thing after expression. Integer vector a n. Undeclared identifier vector. I did include vector. That is how you include vector, right? Include vector. And then I can just, or maybe I can just include this thing. Bits std c++. Editing is disabled. Blah, blah, blah. Okay. Copy back, place, include. What was it? Bits std bits std standard c++.h. Okay, I have to include vector.h instead of vector.h. Okay, let's see. Waiting for judgment. WJ. Japanese compiler error. Shit. Vector y is vector unknown. There's some syntactical mistake. Include bits std c++.h cm. That is good. Vector int I space. Maybe the language version 17 is cool. 17 is cool. Clang 17 is cool. Again, waiting for judgment. Unsupported type. Bruh. Das funktioniert nicht. Was kann ich machen hier? Editorial Japanese contest. Shit, it just never works. Well, keeps waiting for judgment. No. This, that. This should not give any error. The only change I did is put a space in here. Taken in x, and then this int I equals 0, I less than n. Start the loop, and if I find it, then output yes and put x equals -1, and if x is not equal to -1, that means I didn't find it, then no. It is still waiting for judgment. And go to division 1 announcement contests. This one. Virtual participation, but I'm not even able to submit stuff. Custom test. Let's do this. And standard input, I will take the input from this thing, from this problem. This one. Let me do this here and run. Let's see, output should be no, or maybe a compiler error. Why is this wrong? Why would you expect this after expression? That is correct. Maybe the version of C++ that is being used, C++, not 30, 20 GCC or 23 Clang, 20 GCC. Let's go with that. Running, so it didn't compile. Integer vector was not declared in this scope. Maybe GCC does not have this thing, but it would say that I am including something that should not be included. Suggested alternatives. Uh, Remove include vector this protected. Okay, that makes sense. That makes sense. That makes sense. Standard vector. That makes sense. Run and running to be updated automatically, and I can make these smaller, big, any size I want. That is cool. Okay, while this is happening, let me go to the washroom and I will be right back. Like, right back. Yup, I am back. And how is that? That thing. Shit, it is still running. Okay. Uh, submit. Here, submit. This one should work. Or maybe not. Why? What is the error this time? See, okay. I can fix that in one go by saying this. Using namespace std, that is the syntax, right? Yes, that is the syntax. Increase size. Uh, yeah, cool. Submit. This time it should work. Wrong answer for one question. Shit, wrong answer for everything. What did I do? Copy and custom test this and that and run. Running, and I said no, which is correct. No is correct. No is correct in this case. No is correct. So what is the problem? Why does this say task? This. Where are my submissions? I can submit this. And it should work. Working judgment. Waiting for judgment. Wrong answer. Wrong answer. Why is it giving wrong answer? Sample text. Wrong. Wait, is it because what am I supposed to output? I'm supposed to output yes and shit. Is it because capitalization? I made yes and no capital. Shit. Was it because of that? It was shit. Now it is correct. That is cool. That is correct. And the one question that I was doing yesterday at Coders, not yesterday, but yeah, yesterday, this one. This one right here. Let me go to that folder. Competitive programming, lspd at Coders. It's dp sheet na frog dot cpp. This is what I wrote, a recursive function and all of that. And how can I see my submissions? My submissions, okay, results, my submissions. So it said that there was a runtime error because of execution time. Execution took too long. 5 correct answers, and then because of the execution time, I guess. All of these are wrong. Okay, this is what I submitted. And what was even the question? Question was this: given n pairs, n stones numbered 1 to n, the height of each is hi, okay, n and hi heights, okay. There is a frog. There is a frog who is initially on stone 1. He will repeat the following actions some number of times to reach stone n. You can either go from to the stone that is like right next to him, or skip one and go to the one alternative next one. Here, cost is the absolute difference between them. That is cool. On the stone to land on Find the minimum possible answer. Find minimum possible. I think this should work. Given a vector, this function takes in a vector and it returns what is the minimum cost to get to the ith stone. What is the minimum cost? And if I am at the first stone, then the cost of getting there is 0. But if I'm at the second stone, then the cost of getting there is coming there from the first stone. And in other cases, if that is not the case, then I see if jumping. So I have two options. I can either come to the current stone from the stone from the previous one, or from stone that is previous to the previous one, and depending on whichever is more cheaper to come to, I do this long abs, long absolute of this thing, the cost of this one, plus the recursive cost of getting to that stone. And if not, is the other one, then do this. That is absolutely correct. And I call this function on the A array, and I need to find the minimum cost of getting to n-1 stone. That is the last one. That is correct. So if I submit the same code again, let's see. One is correct. 7 runtime error. Okay. I cannot even see the runtime error, and not even the problem sets that I got this wrong on. It took a lot of memory and it took a lot of time. Why? When would that happen? If n is 1, what are the constraints? If n is like something is strange, then it might be causing the error. If n is something strange, let's see. N is at least 2 always. Okay, and heights is at least 1 always. Okay, so that should not be the problem. Okay, and I am going here only when I know that I is at least 2. Only then I'm subtracting 2 from I. If But if it is 1 and how to get to that, then that, and 3 and is 2, how do I get to 2? How to see wrong test case and at coders. Click the debug my code button associated with your submission. My submissions. Debug my code button. And this is what. Click on debug my code button associated with your submission. This feature is available for problems in the practice section in the code chef, and potentially on problems at coders. This is what you are looking for. What is this? Error. It's been 2 hours and 25 minutes, and I guess that would be the end of this video for today. But before going, I would like to do one wordle. One wordle. Wordle for the day. Shit, what is this fucking country? Shit. This could be from the Caribbean or Oceania or above Britain. Shit. Hmm. Caribbean. Haiti. Uh, Hawaii. What is the spelling of Hawaii? How Hawaii? Hawaii is not a country. Hawaii is a fucking state. Mm, shit. This is not in the Caribbean. This is not near Africa. This could be in Oceania. Oceania, and I do not remember any countries from Oceania except my Micronesia. Okay, it is in Oceania. Below. This could be Samoa. Very close. American Samoa. Very close. Fuji. I don't know. I don't know. St. Lucia. Micronesia. Nauru. Wilson. First time I am hearing the name of this country. Supposedly, this is a country. Neighbors. I don't know. Samoa. American Samoa. Not there. Fuji. Wallis and Futuna. Micronesia. Not there. Australia. Not there. New Zealand. Not. New Zealand. Not there. New Caledonia. Could be. Could be. But not. Nauru. Nah. I don't know. Shit. Papua New Guinea. Yeah, okay. Fiji. Okay, Fiji, Tonga, Tuvalu. I've heard these names, but I have not heard this one. Capital. How would I know? Futuna is not a country. Shit, I have no idea in this one. Ottawa, Mata Uta, Utu, Mata Utu. Flag. I just have to guess. Wallis and Futuna. Okay, probably this or this. Not a castle, at least. Not a monastery. South Pole, ceremonial. No, no, not this. Could be this. It is this. Shit. This one. Okay. And language. No idea. English. Bahama English. Hindi. Of course not. Wallis and Futunian. Shit. Wallisian and Futunian. These look similar. They are correct. Less than 50,000, of course. 11,000 people only. Watu, Frank. Okay. Yeah. Their most populous city has only 1,000 people. Matautu, which is their capital. Matautu. Phone is running out of battery. Let me finish this thing quickly. And in this, I'm just guessing stuff. I don't. Good guess. I don't know anything now. Export will also come there. Shit. Okay. 140. Okay. This does not export anything. And that would be the end of today's history. And yes, that would be